Hello everyone, welcome back to my channel. So today's topic is carbon cycle. Earlier we have discussed about the nitrogen cycle. Today we are going to discuss about the carbon cycle. So before going into the details about the carbon cycle, let me give you some brief intro about the carbon or the carbon dioxide itself. So in atmosphere, the average concentration of carbon dioxide is 0.03%. Carbon dioxide is the basic source of carbon. Carbon dioxide is found in dissolved form in water, in oceans. It is in large amount also. Carbon is used to constitute all the organic compounds. It forms 49% of the dry weight of an organism. So the carbon dioxide is used by green plants for the photosynthesis by which organic compound is formed. Okay, one part of this organic substance is used as a food by animals, but the remaining part remain in the plants and is given in the form of CO2 to the atmosphere. When plants die and decay, then the organic substance also changes to the CO2. Later on, the cycle continues by the animals, that is through respiration they liberate the CO2 to the atmosphere, and also when they die or their decay change to organic substance, this substance also changes to the free CO2 as a byproduct. So first of all, there are various phases in the carbon cycle, so let's discuss them. That is atmospheric carbon. It is found mainly as a CO2 and also in smaller amount of methane. It is considered trace, that is present in very small amount, but plays a vital role in sustaining the life on the earth and in controlling the earth's climate by trapping the heat in the atmosphere. As we know, CO2 is a greenhouse gas, so it plays an important role here also. Then the phases of the carbon cycle: first is the rock subcycle, that is the long term cycle. It is then the ocean subcycle, it is the short term subcycle. Then the biological subcycle and the fossil fuel subcycle, it is known as the dead end of the carbon cycle. So first of all, the rock subcycle. So, CO2 in the atmosphere react with the water vapor to form carbonic acid. So here carbonic acid is formed. This chemical break down the rocks, which is composed of CaSiO3, and the carbon forms CaCO3. That is, later on CaSiO3 react with the carbonic acid and it forms CaCO3. Okay, which dissolves in the rainwater and is carried to the ocean. That is, it dissolves along with the rainwater and is carried down to the oceans. Then precipitation, warm temperature and vegetation enhance the rate of the chemical weathering, that is of rocks. So whenever we can say more precipitation is there, high temperature is there, or much vegetation is present on the rocks, so the chances of weathering is high in case of particular rock. So carbon in atmosphere due to the action of weathering, that is carbon in rocks, and also due to the process of tectonics, it again got converted into the carbon in atmosphere. Then in ocean, the CaCO3 precipitate out, forming the layers of the sediments on the seafloor. As Earth's plate move due to the plate tectonics theory, as we know in geography, CaCO3 are subducted underneath the continents. That is, continents are the large land masses. So beneath them, CaCO3 got settled down. Under the great heat and the pressure below the Earth, sediment melts, okay, due to the great heat and pressure, and they react with the other minerals, releasing the CO2. So CO2 is re-emitted into the atmosphere through volcanic eruptions also. So this is a diagram representing the rock subcycle. So here CO2 is taken by plants for the photosynthetic purpose. Here it is soil, H2CO3 is present, CaSiO3 is present in rocks with H2O. Okay, so here SiO2 is present, CaCO3 got settled down. So silicate bedrock plus H2CO3 in soil. So here weathering process took place. Then later on, these ions dissolved in the river water, that is transport took place in the rivers, and later on shells of the ocean planktons, that is of made up of SiO2 or CaCO3, they got settled down and deposition in ocean took place. So rock subcycle contains the largest amount of the stored carbon, hence they are known as earth thermostat. Then ocean subcycle. So CO2 from the atmosphere dissolved into the ocean water at a high latitude. So here again CO2 plus H2O, H2CO3 is formed. Carbon is carried to deep ocean by the sinking currents. As you know, ocean currents are present. Then the carbon in the warm tropical oceans will evaporate back into the atmosphere as CO2. Why? Tropical oceans are those oceans which are near the equator. So on equator temperature is very high, so the rate of evaporation is also high. So due to that, again CO2 is sent back to the atmosphere. So this cycle contains second largest amount of the stored carbon, after we can say rock subcycle. Then there is a feedback that is between ocean and carbon dioxide. First is that is cold climate. So less CO2 make climate even colder and dissolves and accumulates in oceans, and the warm climate, that is CO2 evaporate from the ocean into atmosphere and make even climate even warmer because it has the greenhouse gas property. So see, carbon in ocean water due to the property of evaporation, carbon in atmosphere, and later on due to the property of dissolution, okay, it got converted into again carbon in ocean water. Then the biological subcycle. So the most common producer are the plants on the land and the phytoplanktons in the oceans, as we know. So carbon is removed from atmosphere and stored in the producer by the process of photosynthesis. So here CO2 plus H2O, CH2O, that is a carbohydrate, is formed in the plants plus O2. So carbon in atmosphere by the process of photosynthesis, it is converted, used by the terrestrial plants to make their food. Then, carbon from the plants can be consumed by animals or become the organic component of the soil. Also, there are two options. Phytoplanktons consumed by the marine life and they accumulates on the bottom after the death of the consumers. That is, whenever we can say, for example, a fish consumed a phytoplankton. Later on, when that fish died, its body, or we can say, got accumulated or settled down beneath the bottom of the ocean or the water body. So respiration in case of animals, we can say, so CH2O plus O2 got converted into CO2 plus H2O. Aerobic reaction requires oxygen, we know, occurs in the consumers of the plants when stored energy in the organic carbon molecule is utilized. Then in the process of decomposition to CH2O, it got converted into CO2 plus CH4. Anaerobic reaction, it is, so it here no oxygen is required. It occurs in soil, ocean floor, landfills, where anaerobic, we can say, bacteria ferment the organic material. So carbon returns as CO2 and CH4. CH4 will react with oxygen in the atmosphere. Again, as you know, atmosphere oxygen is present, so it will form CO2 and H2O. So this is the diagram. Carbon in atmosphere, CO2 and CH4 by the process of decomposition and respiration. And again, consumers, soil, marine sediment and organic matter is present, and the action of anaerobic bacteria is there. Then the fossil fuel subcycle. So the organic matter is converted to the fossil fuel due to higher temperature and pressure that is associated with the lithification. So here CH2O is converted into CSHX plus O2. Combustion of fossils release CO2 back into the atmosphere. So this is any organic material. Then by the million of years ago process, we can say, fossil fuels, thousands of years ago, by the process of combustion, again carbon is released into the atmosphere. So the soil, marine sediments, due to the process of lithification, due to the process of burial, that is extreme pressure and heat, they got converted into the fossil fuel. So CH4 to O2, CO2 and H2. Then the impact of humans, that is what leads to disturbance in the carbon cycle due to the activities of humans. So increased concentration of CO2 due to burning of the fossils, okay, for example, burning of coal for the production of electricity, deforestation, etc., leads to imbalance in the carbon cycle, okay. Global warming and the greenhouse effect are its result only, okay, as we know. And marine life also get affected because the involvement of marine life is here in the case of carbon cycle. So as you can see in this diagram, atmospheric CO2, okay, taken by plants for the photosynthesis purpose. Then they give oxygen for respiration, that is utilized by animals, and as a food they store it, okay, and convert into the tissue, that is also consumed by animals. Later on animals release CO2 by the process of respiration, and also when their death took place or they decay, then the by activity of decomposers, again CO2 is released into the atmosphere, and by the process of fire, fossil coal, petroleum, natural gas, that is their combustion, they again release CO2 into atmosphere, and by the process of plants decaying also CO2 is released. Then again CO2, that it got converted into CO3, that is utilized by shelled animals, and when they die or decay or by the respiration process, they again release the CO2, okay. And in case of fishes, that is when they feed on phytoplankton or zooplankton, okay, they decay and their calcareous sediments again settle down and got converted into CO2, that is in the sea water. So yeah, this is all top we can say this is all about the carbon cycle. Hope you will like my video, and if you like my video, please do like, share and subscribe to my channel.